Everybody, the, logistic regressions, linear regressions altogether, they are very sensitive to extreme or outlying values in the input space. So to often, we need to regularize the input distributions when they exhibit very skewed, patterns, and we regularize them using a simple transformation. So that's the goal of this tutorial video clip. So how can we do that? Let's find out. So to make a transformation on a certain input, we need to use a tool named transform variables, which is under modify tab. So on the modify, transform variables, drag it, and I'm going to place it actually before we make any imputations. So place it prior to impute and delete the existing link between partition and impute and draw a new arrow from partition to transform variables and then from transform to impute. So literally I inserted transform variables node between partition and impute. And select transform variables node, and then under train heading, select variables. So using this, we're gonna look at distributions of all inputs in the data set to assess which one exhibits skewed patterns. And we will look at the distributions, all inputs starting with a gift. And let's highlight these. And then you can select explore. And we have distribution for gift average 36, gift average all. This one seems to be skewed. This one as well, same. But if you look at the gift time last, this is more like in a bell shape, normal distribution, so we don't need to worry about skewness. Likewise, gift time first also sort of more or less bell shape. So by visually investigating these 10 histograms, or distributions, it seems that we only make transformation on or for the first 8, excluding the last 2. So that's the judgment we can make by looking at visually inspecting histogram or distribution of each input we have. So I'm gonna exit explore, and within this variables window, while these, let me unselect those variables and reselect the first 8, excluding the last 2, and change the method from default to log, the natural log, right? And select OK. So basically we log transform these select 8 inputs, and those log transformed inputs will enter as inputs in the subsequent analysis. And run transform variable node. Yes. The benefit of this log transformation or the variable transformation is improved model performance. So by regularizing input distributions using a simple transformation, one can actually achieve, higher prediction accuracies on a validation set, or even lower misclassification rates or average square errors on a validation set by avoiding, by preventing the logistic models from being too sensitive to outlying observations. All right. And select results window, results button. And the bottom 8 rows, they are the newly created inputs. So using log transformation and Enterprise Miner inserted +1, basically added 1 to the original variable, because when the original variable takes the value of 0, without adding 1, log transformation cannot be computed. So to avoid that kind of problem, it added an arbitrarily small number such as 1. And basically these 8 are new inputs, which are created by running this transform variables node. So with this, we're going to rerun the logistic regression. So let me exit the results window and run the regression at the end of the connected nodes. Since we inserted the transform variables, as we are running regression node at the end, especially the impute will be rerun based on the 8, based on the addition of new 8 variables onto the existing variable set. So let's see how that affects the final outcome. Note that we haven't made any changes with respect to the properties for logistic regression. We still opted in stepwise selection model, and with validation error or average square error as our preferred selection criterion. So the only change is we added 8 additional inputs, the log transform values of 8 existing inputs, and see how that affects our result of logistic regression. Right. Select results. And I'd like to see the iteration plot to see where the new optimal level of complexity is located. So let's view model iteration plot, and since we minimized validation error, which is same as average square error, this is the right chart. Unlike the previous one, before we added 8 log transformed inputs, previously the vertical line was drawn at step number 12, but now it is reduced substantially is now drawn at step number 4, indicating the fact that using only 4 inputs, we can actually minimize the average square error on a validation set. This is quite remarkable, I would say. And let's see, what are those 4 select inputs? So let me exit this and maximize the output. And scroll down all the way to the end of this result. 3805, that's the one, 3805. There you go. So it summarizes, besides the intercept, which is the sort of entered as by default, these are 4 select inputs, and the median home value, gift time last, and then these 2, gift count 36, gift average all. Notice that these 2, third and fourth inputs, they are not original nominal values, but they are log transformed. So you can see that by applying log transformation, these 2 variables were created and they entered as important inputs as we ran a stepwise selection model with the goal of minimizing validation error. So you can clearly see that this is the benefit. As a result, now the optimal level of the model complexity, it was shown to be 4. So only 4 inputs enter the model. Okay, so that's all I need to discuss. Let me exit and stop recording this clip.